What if there is a source of energy that the majority of people don't use anymore? A cleaner and more stable fuel that is hidden within ourselves. Today, we talk about the lost energy fuel of the human body. Hello amazing people! How's it going? My name is Tommy. I'm a human nutrition student and researcher at the university. My job here is to consume a lot of content in the health topic so you don't have to. And then I explain and teach you the best and most valuable information you need to know. Okay, so first we're going to view what energy source the majority of people uses. That is glucose. Glucose comes from the exterior in form of carbohydrates. We eat food that contains glucose and then we metabolize it and create energy out of it. The pathway in the cells is the glycolysis, and then from glycolysis we create pyruvate, and from pyruvate acetyl-CoA. And acetyl-CoA is this molecule that can enter the Krebs cycle to obtain NADHs and FADH2s. Those are going to the electron transport chain to create finally ATP, our molecule of energy. So having that in mind, we have to know that the extra glucose that is not going to create energy, we're going to process it and create glycogen to store that glucose for later. So in case we don't eat, we can still have a glucose source from the glycogen we have in our liver and in our muscles. This is what the body does normally. The 99% of people work like that. So we talked about how the mitochondrion uses the glucose. Now let's talk about how the mitochondrion uses the fat as an energy source. And when I say fat as an energy source, I mean no glucose. We will see that in a minute. We have the fat, and the fat is going to be degraded into fatty acids. If it is a triglyceride, for example, we have the fatty acids, and the fatty acids are going through the beta oxidation to then create acetyl-CoA. Again, acetyl-CoA is the molecule that can enter the Krebs cycle to get NADPH and FADH2s to go to the electron transport chain and create ATP. But you have to know that one fatty acid, for example a palmitic fatty acid, 16 carbons, creates a lot more energy, a lot more acetyl-CoA and indeed ATP than a molecule of glucose. The difference is very high. I'm talking about 32 ATPs from one glucose to more than 100 from one single fatty acid. So as you can see, we're going to create a lot of acetyl-CoA indeed. And this molecule is very interesting because when we don't have glucose in our diet, we're going to prioritize, as I said, the beta oxidation of the fatty acids we ingest with our diet, but also those ones that come from our body fat. Doing that, we're going to create a lot of acetyl-CoA, and this molecule can be bound to another one. So two molecules of acetyl-CoA are going to be bound together, and from there and all the modifications, we're going to create the hidden energy fuel we can have, which is the ketone bodies. This is the lost energy fuel of the human body, the ketone bodies. Why? Well, if you didn't know, when we were born, we were in ketosis. And ketosis is the state of the body in which we use ketones, ketone bodies, as an energy source. When we have a lot of fatty acids that come in and we are going to create a lot of ATP, when there is already too much ATP, then we are going to start collecting acetyl-CoA. And acetyl-CoA bound to another molecule of acetyl-CoA will create ketones. And ketones then can travel to different tissues, get inside the mitochondrion, and guess what? We can divide that and we have already two molecules of acetyl-CoA. And that's very fast for creating energy. And it's also cleaner and more stable, since we don't have to go through the processes of either glycolysis or beta oxidation that can create residues such as free radicals in some cases. So you have to know that ketone bodies are produced in the liver. and they can go to any tissue in the body. When you start to adapt to ketone bodies, when the formation of ketone bodies is increased because you are adapted to them, you are keto adapted, as they say, that means that the priority is to send the ketone bodies to the brain, because the brain uses the ketone bodies more than the other tissues, and in some way the ketone bodies are better for the brain because they can lead to a better concentration, and the energy levels throughout the day, as well as mental energy, are going to be much more stable than with carbohydrates and insulin peaks, for example, which are going to put us on energy tiredness all the time. So when we feel tired, we have to eat, and after eating we will feel energetic for some time and then eventually tired again. With ketones, that doesn't happen because the energy provided is more stable throughout the whole day. The rest of the body, though, will use the fatty acids as an energy source. The fatty acids can come from fat, the body fat we have in our body, so we are going to lose fat, and also by the fat we ingest with our diet. This happens only if we don't eat carbohydrates. If we eat carbohydrates, the mitochondrion is going to switch back to the glycolysis pathway and prioritize that and shut down the path to create ketones. When we are in ketosis, the glucose we have in the body is still created from proteins, for example, or from the degradation of triglycerides. We can bound 2 molecules of glycerin, create glucose, and that glucose is used for the maintenance of the blood glucose levels. And the blood glucose levels are going to be in a pretty optimal state all the time, because glucose is only going to be used for that and for some neurons in the brain. And here I have a bonus tip for you. The keto diet creates ketones, fasting creates ketones, and we reach ketosis if we have ketones indeed. So there are 3 ways to reach this state of ketosis. The state in which we use ketone bodies as energy source, and we unleash the hidden energy fuel of the human body. These are the keto diet, that is very, very low on carbohydrates and high in fat for creating those amounts of acetyl-CoA we need for the ketone production. Fasting also can create ketones, because if we don't eat, we are not going to spike our insulin, there are no carbohydrates coming in, and we are going to use our own body fat. The mitochondrion is going to prefer the beta oxidation pathway and use the fatty acids. But before that, the body tries to create glucose from proteins as well to keep going with the glycolysis and indeed use glucose preferably. And the third group is the athletes that exercise so much that can use all the glucose in the body stored as glycogen, all the glucose we can find in the liver and in the muscles. And after those 2,000 calories burned, then chances are they are going to create ketones from their own body fat to continue the exercise. So these are the 3 ways to enter ketosis, to create ketone bodies, and to use the lost energy fuel of the human body. Okay, so we reached the end of the video. I hope you understood every concept I explained. And if you have any doubts, there is a comment section down below. Remember to like, subscribe to the channel, and turn on the notifications so you get notified every time I upload a new video. Share this video to friends and family. Thank you so much for watching, and I'll see you in the next one. Ciao!